I am Sarah Gerke, the managing editor of Fabeloo, and it's a pleasure to be here today joining the great team from RISE to discuss trends in 3D printing for production. As we all know, 3D printing is a very fast-growing technology and an industry in its own right. With roots in prototyping, it's moving quickly into production. So we're here today to talk about some of the challenges ahead and the ways that we're addressing them, particularly in polymers. So we'll start today with a quick overview of the market, looking at the shape of it and participants, as well as some of the promises of additive manufacturing, barriers to entry and the tech challenges ahead, as well as a look forward into what's being done. 3D printing was first commercialized in the 1980s, beginning with stereolithography, or SLA, and fused deposition modeling, or FDM technologies. It was used so significantly in prototyping that it was often referred to only as rapid prototyping. It has advanced over the last several decades into a rapidly growing industry in its own right, and is today making its way into end-use production applications. So let's take a look at the shape of the market today in 3D printing. The Wohlers Report is one of the most valuable resources in 3D printing today, and each year, Terry Wohlers and his team of experts put together a significant study looking at the shape of the industry. The 2018 report revealed that in 2017, the 3D printing industry was valued at $7.3 billion, with 135 companies worldwide producing and selling industrial additive manufacturing systems that year. This was an increase from 97 companies reported in 2016. A lot of the focus in both the Wohlers report and in general industry these days is on what they call the dramatic rise in metals. We're seeing a growth of nearly 80% in 2017 from levels in 2016. But of course, we know it's not all in metals. That's just where the most noise is. One of the very first production applications for 3D printing was hearing aids. It's an incredible use case because within 500 days, nearly the entire hearing aid industry switched over from traditional manufacturing to 3D printing for final use hearing aids. Anyone having a hearing aid made today will typically have 3D technologies, including 3D scanning and 3D printing, used to make their hearing aids just for them. Of course, another significant use case for end-use applications is for complex parts, typically seen with metals, such as the very famous LEAP fuel nozzle made by GE Additive for the LEAP engine. Use cases like this leverage the benefits of additive manufacturing, such as combining parts. This one took 20 parts into a single assembly made in one part, which weighs 25% less and is 5% more durable than the legacy assembly. Fuel efficiency has been increased by up to 15%. Such cases represent a very significant application area for additive manufacturing. And especially as GE recently reported their 30,000th fuel nozzle made, we're seeing milestones marked throughout additive manufacturing. So where is 3D printing used in production today? Many of the most common applications that are correctly and viably seeing additive manufacturing put to use include tooling, jigs and fixtures, spare and replacement parts, customized, one-off and short-run products, high-end aerospace components, and medical devices. We see here an image from RISE where printed fingers were made with sandpaper glued to them. So why do companies turn to 3D printing? What promise does additive manufacturing have over other technologies? Many of these are touted by the industry as 3D printing can deliver freedom of design complexity, lightweighting, reduction of parts, reduction of costs in terms of materials, labor, and assembly, localized production, bringing supply back onshore or back into local areas, as well as on-site production, bringing 3D printing, bringing production directly to you, and automation. With the RISE 3D printer in particular, we're seeing that it can be used in an office setting, as this image shows. But why isn't 3D printing on every production floor yet today? We're seeing significant barriers to entry remaining in terms of materials options that are lacking, training and upskilling being minimal, as not so many people understand how to use the technologies or have been completely trained in them. Repeatability in terms of the quality achievable, making the same part the same way with the same qualities every time. Qualification and certification, if 3D printed parts don't stand up to or surpass the regulations needed in any sort of traditional manufacturing, there would be no point in adopting a new technology, as well as the upfront costs of adopting and installing an entirely new technology base. Challenges on the technical side lie primarily in design for additive manufacturing, as when you're adopting a new technology, it's not just making the same parts in a different way. Parts can be completely redesigned, such as with topology optimization and other ways of taking advantage of the unique geometries available via additive manufacturing. Speed needs to be addressed, as 3D printing is still not typically seen as being an especially fast technology in many cases. Scale, which is still limited by the build envelope and production capabilities, as well as the post-processing required for most technologies. Once a print job completes, it's not often ready to just be taken immediately off the bed and put to use. When I speak to the team at RISE, they all show great understanding of where 3D printing is today, where it's going, and why it's important. I was speaking with Kishore Boylakuntla recently, the Vice President of Product, and he said that one thing is clear. Additive manufacturing is disrupting and is going to further disrupt every branch of engineering. When we spoke about how and why he came to join the team at RISE, he noted that it offers a very unique technology that's going to change the game in massive, scalable ways, and he wanted to be part of that. The platform thinking and unique technology available with RISE was incredibly appealing to him to join that team and look at scaling this robust hardware and software suite. So when we look ahead at 3D printing for production, we see that challenges are being addressed and that new technologies and teams are working together to address existing limitations in terms of reliability, consistency, and repeatability, speed, scale, cost, upskilling of their teams, safety in terms of using production equipment in any setting, avoiding the hype that we're all so familiar with from 2012 to 2015 in particular, and then looking at a full ecosystem or platform thinking technology. It's not just one thing, there's not just one solution. It's not only hardware or software or materials, but all of these things have to work in tandem and create something completely new that can be taken into production. With that, I'd love to turn this over to Andy, the CEO of RISE, for a discussion on some of the more specific areas that RISE is addressing.
So I was taking off where Sarah left, which is how companies are going through this journey of additive. And I think the first step in the journey has been to look at parts that exist today and how do you use 3D printing to shorten the time to do prototyping, do quick tooling, especially custom tooling, be able to do at a lower cost and do it much quicker. This involves no change in the product, no change in the supply chain, which means you're pretty much doing things the way they are being done right now, except that 3D printing is helping in doing this cheaper and faster. Where 3D printing technology is going, and I guess Sarah alluded to this, is how do you change the product design to fully leverage the technology of additive, which is being able to do generative design, do lightweighting. The GE example is one of them. So really drive a significant cost reduction in the product, in the end product, especially products that are produced for manufactured products, and also create new functionality that was never possible before, hence being able to do more for the end customer. So that's where product change is happening. And the second area where things are changing is how do you produce parts at the point of consumption, which means not just put the additive manufacturing in factories, but put additive 3D printers at the point of consumption where people can print parts on demand and consume them. And that's where the supply chain evolution is happening. And a combination of this really gives you the ability to do business model change, which means that you can create new business models with additive that were never there before. For example, we here heard the example of hearing aids. There are numerous examples coming out in terms of additive first businesses. Now, our focus in RISE has been to enable all of this at a desktop level. So our promise has been, how do we provide a desktop industrial 3D printing environment which can be available to end users to print parts, industrial parts. And before I talk about RISE, I want to just define the problem and define the statement of what desktop industrial 3D printing should be. So desktop, the three words, desktop, industrial, and 3D printing. Desktop, something is a desktop when it is simple, speedy, and very safe to use, which means it doesn't require any expertise. It can be done with, like a one-touch experience for pre and post processing. And it's completely safe. It has no gases, no chemicals, no glues, nothing. So that really constitutes a full desktop kind of environment. Industrial is when you are able to get parts which can mimic an injection molded part, which means it should have strength along all the three axes, X, Y, and Z. One of the challenges in 3D printing has been always getting the Z-axis strength, which has limited the usage of 3D printing and additive. The second is the ability to do diverse applications, prototyping, tooling, molds, end-use parts, all applications, not just a limited set of applications. And the third, industrial environments are environments which are operating in all kinds of conditions. So the additive technology should be remote areas, any of the things that challenge the printer in terms of its physical presence. Really play into the full digitalization theme, which is Industry 4.0, which means that it should be digitally connected to Industry 4.0 technologies, or it should have at least the potential to do so, which is things like blockchain, augmented reality, virtual VR, etc. And really, you should be able to drive multi-material capabilities with a single technology so that you're able to provide a platform kind of approach. Now, all of this has to be done at a really low cost of ownership. Today, the cost of ownership of 3D printing is so high that it is unaffordable to buy too many 3D printers. And that's why one doesn't see the wide-scale adoption of 3D printing, because even if the cost of the printer is low, relatively affordable, the cost of ownership, which is the person cost to operate it, the material cost, all of that adds up to a significant cost. And that makes relatively widespread usage relatively limited. So what we try to do with 3D printing is, yes, we know that 3D printing and additive manufacturing really does things much faster and quicker as compared to traditional manufacturing. Something that used to take 6 weeks to do can be done in days, and sometimes in a day or two. But still, there is a lot of effort in getting the part ready for 3D printing, which is called pre-processing, and the part ready for end usage after the part comes out of the 3D printer. In fact, one engineer told me at AMUG that 3D printing is a 21st century technology till the part comes out of the printer. Then it drops to becoming a 19th century technology because of all the work that you have to do on the part. So what we've tried to do with RISE is to say, how do we eliminate this or reduce this pre and post processing to the minimum so that end users can do it, and they can do it, and you can place the printer right next to end users. And there is no need for the end users to send the machine, the part far away. Or for people who run additive labs, how can they augment their current additive capacity to provide better service to their users by turning around the parts quicker? So that's been the value proposition that we've gone with. And I want to just show you an end-to-end process of how all this comes together. So this is a user using SolidWorks, and what we've done is we have put in a plugin into SolidWorks, where from inside SolidWorks you can export the CAD file into our pre-processing software, which is basically, it's called OneTouch, RISE OneTouch, where you basically align the part. You don't have to worry too much about how the part is to be printed, except you want to minimize the supports. But otherwise, because we have strength along all three axes reasonably uniform, X, Y, and Z, the part will print pretty well and behave well regardless of how you print it. But the software also automatically takes care of alignment. But most importantly, what we do is we are able to put in text and images, things like QR codes, which enable you to connect this part, the physical part, back to the digital part. And not only do you connect it to the digital model, you also connect it to all the attributes of that model. It could be, you know, a revision number, it could be material, who did it, why was it done, all of that. All of that information can be put on the part. Now, what our pre-processing software does is automatically prepare the job for the printer and send it by Ethernet, or you can bring it on a memory stick and stick it in. And then all the end user has to do is put in that build plate that you just saw, and it's a magnetic build plate, so it sets itself. And then just select the model and push one button, and the printing is on. And you see the printer up, it aligns itself, it levels itself. There's a 6-point leveling that happens. And then the printing process starts. And you see there, the printing has a hybrid process, which has an extrusion and a jetting process. And I'll show you how that works. Once the leveling is done, the printing process starts. And you see the printing of the material. It's a single extruder, which prints both the material and the support from the same extruder. Most other machines do it through two extruders, and they do a separate material for support and a separate material for the part. In our case, we're using the same material, and that the benefit of that is that when you remove the support, you get extremely smooth surfaces, no rework to be done. So here you see the print process, and it not only printed the part, but it also printed the text and images. And you take this out, take it off the build plate, and just remove the supports, like peeling it off. It's like peeling an onion. And all you do is peel off all the supports. For the supports that are a little hard to reach, you may need a small, tool. Other than that, part just by clicking on that QR code. So what we have tried to do with 3D printing, and especially industrial 3D printing, is make industrial 3D printing simple, safe. It's a zero emissions machine. It's people safe. It's environment safe. It's speed. Speed is not just about the printing speed, but getting the part in the hand, and then ensuring that you get very strong parts. We're doing it right now with RISE 1, with Risium, which is our first machine. We're bringing out other new innovations. You'll see color, you'll see composites, you'll see a lot of different things coming in. And this is software, which is materials. All of it we are working on. So we provided the entire stack so that you don't have to go and shop around. Everything is delivered as a single one-stop shop. Now, does that mean that you can use only our material? We are also working with other materials, new materials from different vendors, so that we offer a lot of different material options. Now, what you saw on the printer is the support being laid out. You must have seen that in the video. And then what you could not see is the jetting, because that happens at a voxel level. And then these jetting inks are basically two kinds of inks. One was the release ink, which enabled us to remove the support. And the second was the marking ink. And that's how this process works. Now, Fabulous, thank you, Sarah, for that report that you made out for this industry in February, where you said that RISE has the ability, using the inkjet technology, to do a lot more, and we are seeing that. The ability to do full color, the ability to print inside the part embedded circuitry with conductive inks, so that we truly create intelligent parts. One of the things which we did was also to innovate on the material. Now, there are a lot of materials available in the industry today. There are more than 60,000 polymers. It's impossible. Quite a few that are being used. When we decided to create a material, we said we wanted something which was strong, which was totally safe, which had the ability to be used in all weather conditions, so it had negligible moisture absorption, and had some very good properties for different industries, especially good electrical properties, good chemical properties. And we created Rhizome 1, and Rhizome is becoming really a very, very good material. Now, we are not limited to Rhizome 1. We will be introducing, as we mentioned, other materials. But this is the first. The other thing we have done is we have extensively worked with software vendors. We partnered with Dassault Systems, we partnered with PTC to really do what we call one-touch 3D printing. And as I said, we want to connect the digital model to the physical part so that there's a digital thread all the time, and you're able to see full digital continuity between the model and the part. This further enables you to use a lot of Industry 4.0 technologies, leverage it for augmented reality and virtual reality, and also do blockchain kind of applications. Safety has been a very important part for us of what we do. Our machine is a zero emission machine. Most of the 3D printers are not. We are a machine which does not require any labor, any chemicals to remove supports, minimal effort required to remove supports. The material is food safe and people safe. And of course, you have 100% authentication through that traceability and the marking. So really, safety is very, very important for us, industrial safety. And industry factories today have got a high consciousness of safety. One of our customers actually printed a very interesting application, a safety application in a big plant where they had a record of what they call a recordable incident, an accident. And RISE was used to print parts right there in the plant and help prevent safety issues. Now we have got a great set of customers that are using our printer and our technology. One of them is New Hudson Facades. New Hudson Facades is a New Jersey-based company, which is an architecture, engineering, and construction company. They have a 180,000 square feet facility where they're doing a lot of innovation and manufacturing. They bought our first printer, and it has been stunning in terms of the kind of metrics they've given us. On a single printer, they have seen investment returns of $50,000 or $60,000 per quarter. They're saying that they will save about $200,000, which means basically they're buying is now less than $50. Amazing speed in terms of inspection assembly times. The interesting thing was that they did not train a specialist for the printer, just as we would like them. They took their existing CNC programmers, their existing engineers, and made them use the printer without. They are today producing end-use parts for fixturing, for gauges, even for production. You see some of the parts that they have. You see on the right this part that they have, which houses one of their facade pieces. And you see it's fixtured and it is also labeled. All of that is done. These are some of the parts. They're printing even big parts, which go beyond the size of our printer in multiple pieces and then joining them. This is an amazing case study. Another amazing set of case studies comes from the US Army, where they are using spare parts in the field. Main reason why they looked at our printer was the ability to do traceability, the ability to do serial numbering, many applications emerging. Of course, many of them we are not able to share, but some of them that we can share. This is an example of a soldier's, basically a grip that is used for improving the performance of using a rifle. There are these things that keep breaking, like for example, in a Humvee, the window knobs, handles, they break very easily. FDM machines, and it used to take a lot of time for the part to come back in the hand of the user. We are able to cut that down very dramatically. There's also an interesting example of a generator wrench. So service parts are a great example for us, because those, they get broken and they hold up an entire production line or a production or a service line, and you need something done very quickly, and the RISE printer comes in very, very handy to do that. An interesting use case for us is HMS Industries, a relatively small company, but they are using fixturing. They are using it for jigs and fixtures, especially to hold parts during their CMM quality inspection. But they're also using it as a sales tool. So they are actually printing complex parts and using it as a quotation. So they actually print on top of the part the price and all the details and send it to their customers like a physical quote. And that has improved their customer satisfaction. They love it for that. They have a huge number of other applications. For example, they have these robot fingers that Sarah talked about with sandpaper glued to them. They have a transmission clutch alignment tool. So they're building tools on the fly. And because the printer is next to the end users, they try many things. Some things succeed, some things don't. But out of that comes a new application. Another customer of ours in Detroit is a company called Azoth. And Azoth works with a number of different automotive companies. They work with Ford, General Motors. One of the applications that they had was around a fixture detail, which holds a stamping component. And this part really had no supplier. It was an outdated kind of part, and they didn't have any information about who the original supplier was, and they reverse engineered the part and 3D printed it. And something that would have taken 6 to 8 weeks was done in less than 48 hours. In General Motors Warren plant, there was a safety incident, and they used a 3D printed part to avoid further safety issues. They've used it for doing precision arbor holders. They've used it for fixturing. One of the interesting applications has been on a air spindle gauge bench, which is basically a bench which is used to assemble parts. It's a hydraulic assembly, I think a pneumatic assembly plant. And here there was a pulley that broke, and this would have taken them about 6 weeks to produce, to get it done from a supplier. They were able to 3D print it overnight and put the entire air spindle gauge bench. This would have kept a few workers idle. They were able to get all that back in production in no time. So we do have a lot of different use cases coming in every day as people use our 3D printers. We've got a bunch of customers now that are using it for production-related applications, and that list keeps growing. There are many technologies available today, and some do some jobs very well. Where we have tried to focus is on time to part, which means how do we get the part in the hand of the user as quickly as possible. How do we lower the cost of ownership when you don't have to put an expert to manage it? Or if an expert is there, then he doesn't have to spend too much of time managing it. And they love the machine because they don't have to put any additional effort to manage the machine. They can use their time for the bigger machines that they have and print bigger parts on those machines and let this machine be almost an unattended operation. In terms of quality, we do deliver on strength and reasonably on surface finish, but safety and chemical resistance are two very important areas for us. There are other printers and other technologies which do some things better than us, and they do some things, we do some things better than them. So I think there's always a trade-off in terms of what you want. But I think the main things that we enable is the fastest time to an industrial part. That is really what defines us, and that is what really helps end users get value out of what RISE delivers to them. A lot of good customers now developing. We have a growing list of customers. We also have, a lot of resellers in the market, which are close to customers and helping them in this process. As I said, deep partnerships. There's good acknowledgement about what we are doing. We just won from IDC. We were among the top 4 innovators of the year. From Frost & Sullivan, they awarded us a best practice award for zero emissions 3D printing. So there's a good recognition of what RISE is coming in to do. Our idea is to help 3D printing connect different stakeholders. So we want 3D printing to be not just something that sits in a corner and is seen as a nice boutique kind of application, but something that works in the daily lives of engineers, whether they be in design, manufacturing, tooling, and service, which really enables them to use 3D printing as a way to communicate. One of the big areas of focus is right now on tolerancing, where engineers tolerance their models, and eventually those tolerances have to be accepted by manufacturing and by supply chain. One of the interesting things we are doing with RISE is enabling the communication between design, engineering, and manufacturing and supply chain to ensure that this whole tolerancing issue is done in the most expeditious fashion. So the number of applications keep growing because it is very close to the end users. What we love about the feedback that we are getting is the return on investment. Under 4 months from many of our customers, which really points to the fact that they realize that this machine can be used and can be used like a workhorse. And of course, the cost reductions are there, which we've seen in 3D printing. Ours maybe a little more because of the fact that there's no cost of labor, but 3D printing overall delivers quite a significant cost reduction. Thank you from my side, and I'll let Sarah say any closing comments. But from my side, it has been a pleasure to thank you for joining this webinar. Feel free to work with us on parts that you may have in mind and problems that you may want to solve. I think in 3D printing, it's not just about the part, it's also about figuring out what kind of problem do we want to solve. Do we want to solve a tolerancing problem, a supply chain problem, any of these problems? So feel free to ping us on those problems and those parts, and we'll be more than happy to work with you on all of those. Okay. Sarah, any closing comments?
Wonderful. Thank you so much to Andy, Julie, and the team at RISE. It's been a pleasure to be here for Fabaloo today and to join with you in presenting this. 3D printing for production is a huge topic, and there's always so much more that could be said. We just talked for almost an hour, and there's already, that was still very high level overall, and there's a lot more that could be said about all of these topics, trends, and all of the solutions that RISE presents. And I know that for our part at Fabaloo, we always look forward to following what's going on in all of these areas and keeping up with the team at RISE and everyone who's really looking to present viable real-world solutions as 3D printing moves into production. So I definitely invite all of you to come check out what we're doing at Fabolou to keep reporting honestly and with some deep analysis, insights, and interviews on the industry, and as we keep up with the great team at Rise. So thank you so much.
Partnership, and I think there's a lot to be done together, together with all our customers and all the people that are on this call. I think the journey has just begun. The exciting journey is ahead of us. Thank you, and with that, we'll close this call. Thank you all. Have a good day. Bye for now.